Welcome to the pre-calculus video for skill number 20. I can find the average rate of change using function notation. And the trivia question for today is, when you are orienteering or finding your direction by compass, what does the term azimuth mean? Alright, so this skill is about rate of change, and this is probably a pretty straightforward skill which has heavy carryover into calculus. Calculus starts by talking about rate of change and starts to examine average rate of change. So a rate of change, it describes how the output quantity changes in relation to the input quantity. If it's within the context of a problem, you can say you have output units per input units, like miles per gallon, or dollars per hour, etc. So the way we find the change of output, or the average rate of change, is we take change of output divided by change of input, and we can represent that with delta y, which is the Greek letter meaning change. So change in y divided by change in x. Or if you wanted to, you could write it using function notation. Or you could use it using the notation we're pretty familiar with, y2 minus y1 equals x2 minus x1. And the observant student will notice that this is just the equation for slope. All you're doing is you're finding the slope between 2 points. And the slope is the average rate of change. It just happens that we can find the slope between 2 points that are not on a straight line using this as well. So my first example, we're finding our average rate of change from a table. So we're given this table below, and it says that this models the function p of t, which is your price for a movie ticket based on the year. And we're asked to find the average rate of change from 1987 to 1999. And then we're also asked to find the average rate of change from 1999 to 2009. So from 1987 to 1999. So 1987 to 1999, we want to look at the change in price to the change in year. So our year of interest is 1987 and 1999. So our change in price goes from $5.06 down to $3.91, and our year is 1999 down to 1987. Crunch those numbers into a calculator, and you get approximately 0.096, so basically 10 cents per year, or $0.1 per year. So each year, ticket price is raised by approximately 10 cents. Moving on to the next page, we'll look at the average rate of change from 1999 to 2009. So we're looking for the average rate of change from 1999 to 2009. So we're just going to do the same process, the change in price over the change in year. So we've got 750 down to 506, and the year 2009 down to 1999. And we find that it is approximately, or exactly, 0.244, which means that ticket prices were raising at nearly a quarter a year. So originally, the first window, we were going up by 10 cents per year, and then we're going up by 24 cents per year. So nearly 2.5 times as much in the latter half of that chart. In addition to being able to do this rate of change from a table, we should also be able to do it from a graph. And below, I have modeled the function f of x in the graph below, and this could be representative of anything. Perhaps this is the price, I don't know, thousands of dollars, stock price or something on a weekly rate. So what we have is a stock, and this is the price. And you can see that over the course of the 5 weeks, the price slowly climbed, and then it started to drop, and by the 5th week it had dropped to about $1,000 a share. So if we want to find the average rate of change from week 1 to week 5, we're going to do the change in price over the change in week. So that means we want to take f of 5 and f of 1 and divide that by 5 minus 1. So f of 5 is 1, and f of 1 is 4. So we have 1 minus 4 over 5 minus 1. That gives you negative 3/4, which within the context of the problem you're saying basically we're losing about $0.75 per week on this share. Obviously not a very good investment in the short run. Alright, let's look at example 3, which is doing this from an equation, and it says find the average rate of change of the function x squared minus 7x on the interval 1, 8. And here we don't have units, we're just looking for change in y over change in x, which means we're going to find the f of 8, and if we plug that in we get 64 minus 56, which is actually 8. Then we want to do f of 1, and f of 1 is 1 minus 7, or negative 6. So we get 8 minus negative 6, which is 14 over 7, and we find that equals 2. So the average rate of change on the parabola on the interval 1 to 8 is 2. And if we wanted to look at this graphically, what we have is some sort of parabola that does that. And f of 1 is down here. F of 8 is somewhere up here. The average rate of change between those 2 points is 2, which means our slope of that line is rise 2, run 1.
Would you like something to drink? She opened the fridge. We have water, milk, juice, spiders, Dr. Pepper.
Spiders?
Spiders it is then.
No, that wasn't.
But she was already pouring him a brimming glass of spiders.
Alright, thanks for watching the video. We should be able to find the average rate of change using function notation either from a table, from an equation, or even perhaps from a graph. Any method of presenting a function, and we should be able to find the average rate of change. The trivia question for the day was, what does azimuth mean in orienteering? And azimuth is your measure, basically your target angle. So if I wanted to walk in this direction, my azimuth would be measured as approximately, we'll say 40 degrees off of north. So your bearing direction, and that's usually measured off the reference angle of north. So if you're walking due north, you'd have a 0 degree azimuth. If you're walking east, you would have a 90 degree azimuth. If you're walking south, you'd have a 180 degree azimuth. Alright, thank you for watching.